Hi and welcome to my mess. Some time ago I bought an antenna. It's a Chinese multi-band antenna called either JPC-12 or PAC-12, PAC-12. It's an amateur radio antenna for high frequency bands. I also bought a longer radiating element, 5.6 meters, but there's one problem with this antenna, that it doesn't support 3.5 megahertz band, 80 meter band. So I made a coil with trial and error. This is the coil. We'll take a look at it in a moment. Will it focus, or do I need to focus manually again? Yeah, sort of. It's just some polyamide, I don't know, material. It's just to make it stiff, some turns here. But there's one problem with this coil. I made it with trial and error, so I wound more and less windings till I was able to fine-tune the antenna of the original coil, because, well, it's quite narrow band with this size of the antenna, with this band. But here's one problem. Well, when I operate QRP 5 watts, everything is okay, but when I operate 100 watts, this heats up, and it's almost, you know, at this point, it's almost too hot to touch. And it heats up so much that it detunes. I don't know what is the mechanism behind this, but it detunes. So maybe if you know what happens, does it change inductance when heated, you can drop me a comment. But anyway, I want to rebuild it, measure this coil and rebuild it. And to measure this coil, rebuild it, rewind it with a thicker wire. So to measure this coil, I will use a nano VNA. You probably know. Oh my god, the light is horrible. You probably know nano VNA. And I will use two capacitors. First I want to measure the coil. So I will use two capacitors. There are two capacitors, 150 picofarads to give me 75 picofarads. Because I roughly measured this coil before, but I want to measure it at the frequency I want to use it. So I will use those two capacitors. I will make a series resonance circuit with it, and we will see the resonant frequency, and we'll calculate the inductance at around my desired frequency. But first we need to calibrate the VNA. Yeah. So let's first calibrate it with open short load. I have a cable connected here. It ends with those crocodiles. So let's first calibrate it. First let's set the frequency, of course. Stimulus. Can you see anything? I want to make sure you can see anything actually. Yeah. Start will be, I don't know, 3 megahertz. Stop will be 4.5. Yeah, so now let's enable the trace. Oh my god, it's not this channel. The phase shift trace. Now let's do the calibration. It's open now. Yeah, it's open. Open. Now let's short it. Well, this is not a nano VNA tutorial, but well, I'm doing it so I can show it. And now the loaded calibration. This is my dummy load I made some time ago. There was a video about it. Load. Yeah, load. Come on. Yeah, it's calibrated, done. Well, we can save it. Okay, so first let's connect my beautiful resonance circuit made with this coil and with those two capacitors, so it's 75 picofarads. And let's see, here's the resonant point, and the light is of course horrible. Here is the resonant point of this circuit. Let's maybe move it here, or maybe let's lower the frequency. Stop, I don't know, 3.5, and start maybe, I don't know, 3. What happened? No, it was already at 3, so let's start at 3.2. Okay, now it's pretty okay. You know, I'm detuning it by touching it, etc. But the rough value, the fine tuning is done by the coil that's with the PAC-12 antenna. 3.386 megahertz. Can you see it? I don't know if you can see it. I just hope you can. Okay, so it's 3.386. Let's use a calculator that I have already opened here. By the way, this is the link they counter. You know, I just put LC resonance calculator and tried several of them. So let's put 3.386. Capacitance is 75 picofarads. Okay, 3.39, 3.3. Okay, so it rounded it. So it's 29.5 microhenry, as you can see. Yeah. Okay, 29.5 microhenry around, because you know, when I move it, it will fluctuate, but around 30 microhenry. So now let's disable the VNA for now, and the phone, and the lights back on. Yeah, much better. Well, maybe not so better, so much better. Now is better. Okay, so let's unsolder the capacitor. You cannot see anything, of course. Come on. It's a thick wire. Yeah. Okay. I will pause while I unwind it, or maybe not. No, because you won't see anything. One moment. Okay, so here is the coil. If you want, you can pause and count number of turns, but it's not really needed because this wire is just too thin. I want to use some thicker wire. I don't know which one right now. Maybe I will need to do 2 layers. I don't want to do 2 layers because of the capacitance, but we will measure the self resonance of the new coil later. It's enough for me to be higher than the 80 meter band, so higher than 3.8 megahertz. So I will try doing it probably with 2 layers of thicker wire, and we will measure it later. Well, unwinding is done, but take a look here. Can you see those dents? No, you cannot, because the camera is trying to focus. Now you can. The wire got so hot that it made dents here. Great. I moved to my another location because, well, I have much more wire here. This is probably 1.5 millimeter wire, if I remember correctly, millimeter squared. It should be okay. Okay, so it's 3.7 megahertz. 3.7. But it fluctuates. It's 3. The focus is horrible here, I know. 3.75. Well, I could add some more turns here. Maybe I will, but it's good enough, I think. But I will add some turns. Okay, now it's 3.32 megahertz, and the display is so reflective. It fluctuates when I bring my hand closer. It's 3.39. This is how it looks like now. Well, it's not the most pretty thing I ever made, but I think it will do the job. I will show you some physical dimensions in a moment. Let me just find my... it will be hard to do with one hand, but yeah. This is the diameter of the cylinder. And the length of the whole contraption. And, well, I can disconnect it. And the thickness. I think it will be good enough. Okay, so let's test it now. And there's one more thing. Well, it's not calibrated for this range, but to show the resonance it will be enough. This is the self-resonance of the coil without those two capacitors. And it's at 30 megahertz around. Another one is around 35, and everything below it 1 megahertz is great. I disabled those other traces. If you're interested, I can show them, but it's messy then. But yeah, at the point of the self-resonance it looks like this. And by the way, this polyamide cylinder has some other uses as well. For example, here it is used to hold one of my other antennas, but it will be another project because I want to make it a... Well, this is a resonant antenna. I want to make it non-resonant and tuned across the range. I don't know if you can see anything, but probably not. So the coil has been installed. It's very dark here. Here's the tuning knob, let's call it, and it looks on the VNA. 3.950. The bandwidth is, you can judge for yourself. I usually take from 1.5 SWR to 1.5. And if I tune it to the other extreme, here it is at the other extreme. Oh my god, I have to widen the range on my start. No, let's say too much. Oh, too much. Start 3 mega. Okay, so it is. Where's the cursor? At the end, it's 3.2, and here's the bandwidth. Okay, now it's tuned around 3.573 megahertz or 3.573 kilohertz, or the FT8, dreaded FT8 part. The bandwidth of the nano VNA is 100 kilohertz. So here's how it looks like. And let's try it. Let's see how it works. and if it heats up and it tunes. And here's the tuning setting if you're interested. Yeah, but it will vary. And I also have to tell you that you won't be able to get the good SWR, yeah, on this original set of counterpoises. I had to make my own. They are longer, I don't remember the length, but longer than those. Here's this how it looks like next to the antenna. You cannot see it probably. One wire, another wire, another wire, and another is here. It's connected here. Here's a choke, quite close to the antenna because I don't want my my feeder to radiate. And here's how the antenna works. SWR is negligible. It's great, I think. And here's how it receives. And here's the waterfall. And it transmits at 100 watts, 12 volts, 15-16 amps around. Here's the output power of the radio. I will show you a menu in a moment. watts, and the SWR is, let's transmit, stays at 1. With that previous coil it already would spike to 1.5 or even higher. After 10 minutes of transmitting, SWR is around 1.1 maybe. It's hard for me to tell, but it's much better than on this previous coil. And here it is how it looks like on the map. Well, I'm heard across the Europe. It's not bad, for such a short antenna. It's not bad. I've been transmitting for half an hour now, and SWR is around 1.3. Definitely better than on this previous coil. Well, this is a signal meter right now. Let's wait for the transmit. I think it's quite good, really. Actually, after an hour of working, I see that the coil isn't warm, but this steel threaded nut is warm. It shouldn't be steel, I just couldn't find anything else. But it should be something else. Well, this part isn't. No, it's cold. Only this part is hot. Okay, so here's the final touch of the insulating tape. I actually wanted to use this heat shrink, but it won't fit obviously. And it's done. And by the way, I think my old radio power supply needs a fan.